Let's look at these problems with fractional uncertainties, right? So here we go. We've got the uncertainty of the area of a triangle. The length is uncertain by 5% and the width by 7%. Okay. Well, the thing you got to know is for zero, right? Is that the what the area is length times width, right? So this is multiplication. When you multiply, you just simply add the fractional uncertainties, right? So 5% plus 7% would mean whatever the answer is. We don't have the length or the width, right? But whatever the answer is going to be have an uncertainty of 12%. And then this is the volume of a cube, right? And the sides each have a percent uncertainty of 3%, right? So for one, basically the volume is length times length times length, right? So it's 3 times that, right? So it would be, the uncertainty would be 3% plus 3% plus 3%, right? Is 9%. You could also use the power rule and get that it's L to the third, and then it would be 3 times 3%. You'd be set. And then number 2 is a sphere. Number 2, the third one, number 2, is a sphere has a radius with an uncertainty of 5%. What's the percent uncertainty of the volume? And these, by the way, these questions are like straight from IB tests. They love to do these. Okay, so a sphere would be 4/3 pi r cubed, or any volume, by the way, is going to have length to the third power, right? So this, if it's 5%, right, this really is 4/3 pi times r times r times r, right? So it's r 3 times, so we would add the 5%, right? It's going to be 5% and 5% and 5%, right? So that's 15%, because it's r times itself 3 times. So these really are not all that hard. I don't have examples of ones where I give you numbers or something like that. There's some in the whiteboards though, so you can look at those.